Hi friends, in this video we are going to discuss about speed control of DC shunt motor. So this is the equation for speed. N is proportional to EB by phi, where EB is equals to V minus IA or A. So in this equation, when we change the armature resistance, the drop will increase. When drop increases, the back EMF will decreases. Okay, so that's why we can change the speed in two ways. Number one, by changing the flux, we can change the speed. Number two, by changing the armature voltage, we can change the speed. And when you observe this equation, N is proportional to back EMF and N is inversely proportional to flux. So finally we conclude that we have two methods to control the speed. The first one is field control method or flux control method, and second one is armature voltage control method or rheostatic control method. So coming to field control method or flux control method. So this is the diagram for flux control method and armature. This is the field which is connected in parallel or in shunt. Okay, and when we give the supply to the DC motor, so the current flows through the first line current flows through the armature as well as field. So armature current flows through the armature and field current flows through the field. In this field control method, we are going to control the flux or we are going to control the field. So by using this rheostat which is connected in series to the field, and initially the rheostat is connected at minimum position. Okay, so when we change the resistance or when we increase the resistance from minimum to maximum, the resistance will increases. When resistance increases, field current will decreases. So when resistance increases, the field current IF decreases. When field current IF decreases, the flux phi decreases. When flux phi decreases, the speed N increases. Why? Because N is inversely proportional to phi. When phi decreases, speed increases. When phi increases, speed decreases. So these two are inversely proportional. But in this case, when resistance increases, field current decreases. When field current decreases, the flux decreases. When flux decreases, the speed will increases. So that's why if you want the speeds above rated speed, we will prefer field control method or flux control method. Coming to advantages of field control method or flux control method. So speed control above rated speed is possible. It is very smooth and easy control. Okay, and coming to disadvantages, we can't vary the speeds below normal with this method. Okay, coming to armature voltage control method or rheostatic method. Okay, so this is the diagram for armature control method. So here the rheostat is connected in series to the armature. Okay, and when we connect the armature connection, it minimum to the rheostat. minimum position. Okay, when we change the resistance slowly and slowly, the drop will increases. So here N is proportional to V minus IA RA plus R. So IA RA plus R is the drop. So this is R and IA RA drop inside the armature. Okay, so when we change the resistance or when we increase the resistance, IA RA plus R drop will increase. When drop increases, the armature voltage, the voltage across the armature or armature voltage decreases. When armature voltage decreases, the speed also decreases. Why? Because speed is directly proportional to EB, where EB is equals to V minus IA RA plus R. Now we added R. Okay, so with this method we are going to control the speeds below normal. Okay, so flux control method gives above normal speeds and armature control method gives below normal speeds. Okay, and so this is the graph. When we increase the voltage, when we increase the drop by varying the resistance, when resistance changes or when resistance increases, the drop will increase. When drop increases, the net voltage decreases. When net voltage decreases, the speed also decreases. So we can see here, this is the normal speed. Slowly and slowly, when drop increases, the voltage, armature voltage decreases and the speed also decreases. Why? Because speed and armature voltage are proportional to each other. Okay, and coming to graph of field control method. So in this method, when shunt field current decreases or when resistance increases, shunt field current decreases. When shunt field current decreases, the flux decreases. When flux decreases, automatically the speed will increase. Okay, so you can see how the speed increases when we decrease the flux. Okay, and coming to advantages. So with this method, we can change the speeds below normal. Speeds below normal is possible with this method. And coming to disadvantages, due to large power losses, it is expensive. So more power losses. Why? Because huge amount of current flows through the resistor. Okay, and speeds above rated is not possible. So we can change the speeds only below rated speeds with this armature control method. Okay, so finally, with the help of flux control method and armature control method, we can change the speeds above normal speed and below normal speed. Okay, in next video we will discuss about Swinburne's test. Okay, bye now.